Hi guys, today we continue to study chapter 5 about heat and matter. The previous lecture video has covered the section 1 through 6. Section 7 talks about gas laws. The first is Boyle's law. It says when temperature is a constant, the volume of a gas is inversely proportional to the pressure. In other words, the product of pressure P and volume V is a constant. For the gas to change from one state to another state, we have P1 V1 equal P2 V2. For example, find the final pressure when a gas with an initial pressure of 300 kPa is compressed from 8 cubic meter to 6 cubic meter without varying its temperature. From Boyle's law, we have P1 V1 equal P2 V2, which gives the final pressure P2 equal to P1 times V1 divided by V2 equal to 300 times 8 divided by 6. Then the final pressure of the gas is obtained as 400 kPa. Another gas law is called Charles law, which says when pressure is a constant, the volume of a gas is proportional to the temperature. In other words, the ratio of volume V and the temperature T is a constant. For the gas to change from one state to another state, we have V1 over T1 equals V2 over T2. For example, find the final temperature when a gas with an initial temperature of 30 degrees Celsius is compressed from 10 cubic meter to 6 cubic meter. From Charles' law, V1 over T1 equals V2 over T2. We have the gas final temperature T2 equal to T1 times V2 divided by V1 equal to 273 plus 30 times 6 divided by 10 equal to 182 Kelvin. It should be noted that the temperature in the physical laws is the absolute temperature. For Celsius 30 degrees, we need at 273 to change it into degree in kelvins. Boyle's law and Charles' law can be combined into a single law called ideal gas law. P times V divided by T equal to a constant, or in the form of P1 times V1 divided by T1 equal to P2 times V2 divided by T2. In general case, i.e. when both pressure and temperature vary, we should apply the ideal gas law. Here is an example to find the gas final temperature by using the ideal gas law. You can read details about this example. Gas is composed of molecules, which are tiny particles that move randomly and constantly. Usually consisting of two or more atoms. Molecules of ideal gas are small in comparison with the average distance among molecules. They elastically collide one another without loss of energy and do not interact except for the collision. In kinetic theory, gas pressure is the result of collision or bombardment by molecules. Boyle's law can be understood because with a certain speed and thus temperature, molecules collide more frequently if they are getting closer. In other words, pressure is inversely proportional to the volume. Gas temperature resulted from the motion of molecules is proportional to the average kinetic energy of molecules. Charlie's law can be understood because with a certain collision frequency, molecules need to move faster if the distance between them is getting larger. That is to say, the volume is proportional to the temperature. That's the Charlie's law. Heat can be transferred from one place to another place in three waves: conduction, convection, and radiation. Conduction transfers heat by molecules collision. Convection transfers heat by the motion of volume of hot fluid. And radiation transfers heat by electromagnetic waves. Liquid and solid are also composed of molecules, but properties of them are quite different. Molecules of solid are firmly attracted to one another. That's why solid has a definite shape and volume. Molecules of liquid can slide past one another. That's why liquid can flow. Molecules of gas can have no restriction on their motion. No shape, no definite size. Matter can change from one state to another state. Evaporating and boiling are two processes with which liquid changes to gas. Boiling point is the temperature at which the liquid boils. For example, the boiling point of water is 100 degrees Celsius. Evaporation can occur at the surface and R temperature, while boiling can occur in the entire volume of the liquid, but at the boiling point or high temperature. That's the difference between evaporating and boiling. The heat required for 1 kilogram liquid to be changed into gas at its boiling point is called the heat of vaporization. For water, the heat of vaporization is 2,260 kilojoule per kilogram. Melting is the process with which a solid changes to liquid. Melting point is the temperature at which the solid melts. For ice, the melting point is 0 degrees Celsius. For iron, it can be over 1,000 degrees. The heat required for 1 kilogram solid to be changed into liquid at the melting point is called heat of fusion. For ice, the heat of fusion is 335 kilojoule per kilogram. Sublimation is a process with which solid directly changes into gas. For example, solid carbon dioxide or dry ice can change into gas directly at room temperature. Heat can be used to do work. Heat engine is a type of machine that can turn heat into work. It operates by taking heat from the hot reservoir, turning a part of the heat into work output, and in the meantime, releasing the part of heat left to the cold reservoir. Refrigerator is the reverse of heat engine. It uses power or work input to take heat from the cold reservoir and releases the heat to the hot reservoir. Make the cold reservoir colder. That's the refrigerator. The first law of thermodynamics is the law of conservation of energy, including heat. Energy cannot be created or destroyed, but it can be converted from one form to another. According to this law, heat added to the system plus work done to the system is equal to the increase of the system's internal energy. Heat removed from the system plus work done by the system is equal to the decrease of the system's internal energy. So we have the formula Q plus W equal delta U. U is the internal energy. Delta U is the increase of the internal energy. This is the first law of thermodynamics. The second law of thermodynamics says that it is impossible to take a heat from a source and change all of it into work without any other changes. In other words, it is impossible to make a heat engine that can turn all heat taken from the hot reservoir into work without any waste of the heat. That's impossible. To describe how big the pot of heat can be turned into work, the maximum efficiency of heat engine is usually defined as the ratio of work output and energy input. It can be derived as a simple relation equal 1 minus the temperature ratio between the cold and hot reservoirs, TL over TH. For example, find the maximum efficiency of the heat engine when the engine operates between the reservoirs of 20 and 200 degrees Celsius. According to the efficiency formula, the maximum efficiency can be calculated and obtained as 36.5%. Here again, we need to add the temperature by 273 to change the temperature to the absolute temperature. Entropy is an important thermodynamic quantity and can be simply defined as a measure of disorder of system. The entropy of an isolated system cannot decrease. This is another description of the second law of the thermodynamics. Entropy changes along the time direction. Since the universe is isolated itself, it will increase its entropy forever. Indefinitely increasing its entropy, the universe will become highly disordered with the same temperature. This is a state of no thermodynamic free energy called the heat death of the universe. This is the end of this chapter. Thank you.